Hi guys, today we're going to continue talking about transformations of the graph. To be more specific, we are going to focus on vertical stretch and shrink and then follow it with horizontal stretch or shrink. So let's just say we are considering the graph of f of x. It doesn't matter which of the six basic functions we're looking at, is we just have some random function. And then we are asked to graph this transformation of the form c times f of x. So the question is, what is going on? Well, we have the function and we are asked to multiply by some number. So in this case, we're changing the function value or the y value. Now, if c is greater than 1, then we're going to have a vertical stretch by a factor of c. I'm supposed to say if the absolute value of c is greater than 1, but for this purpose, we're just going to focus on positive values, okay? That will save us a couple of words. So again, if we're asked to graph c times f of x, we are changing f of x. Oh, sorry about that. We're changing the function value. If c is bigger than 1, then we're going to have a vertical stretch by a factor of c. But if c is less than 1, I'm supposed to say if the absolute value of c is between 0 and 1. But for us, we're just focusing on positive values. We'll touch base in the negative values in a bit. Okay, so if c is positive 1, then we're going to have a vertical stretch by a factor of c. But if c is under 1, then we're going to have a vertical shrink by a factor of c. So let's go ahead play around with Desmos in a bit. So right now I decided to graph the square function because that's my favorite function, okay? So we have f of x equals x squared, and then I highlighted these 3 points right here. Let me go ahead label the coordinates. Desmos is awesome, by the way, and it's free, okay? We're gonna go ahead highlight these coordinates just so you can see what's going on. So we had said if we take some function and we multiply it by c, if c is bigger than 1, then we should have a vertical stretch by a factor of 1. So let me go ahead, graph c of f of x. Ignore the g of x. This is just how I have to enter it on the computer. So let me go ahead, turn it on. And this red graph is now the graph of c times f of x. So let's just say that c equals 2. If c equals 2, then we should have a vertical stretch by a factor of 2. So we should multiply all the function values by c or by 2. So let me go ahead, hover it over it. So we were at 1, 1. And as expected, if c is 2, we're multiplying the function value by 2. So that will give us 1, 2. If c is 3, then we are multiplying the function value by 3. So that will give us 1, 3. And as you can guess, if c is 4, then that will give us 1, 4, and so forth. Okay, so we have a little nice illustration going on right here. The purple graph is the original function, and then the red graph is the function given by c times f of x. So let me go ahead and adjust this right here. I zoomed in and I didn't notice that. Okay, perfect. All right. So again, from the top, the purple graph is the graph of the function or f of x, and then the red graph is the graph of c times f of x. So as you can see, let me go ahead, pause this because this is too fast for me. Let's go ahead back to 1, okay? If c equals 2, we're stretching the function value. If c equals 3, we keep stretching the function value. If c equals 4, okay, I thought this was going to move with my arrows, but it didn't. So we're stretching it. Now, what if c is a number under 1? Then we said that we're going to have a vertical shrink by a factor of c. So let me go ahead, turn off this red graph, and then set this equal back to where it was. And then we go ahead, turn on what the graph of c times f of x is, and we're going to look at the case where c is under 1. So bear with me, okay? So right here, I'm supposed to have c times f of x, but since I already used the variable c, I'm not allowed to use it again. So we're just going to pretend this k is actually c, okay? So if c is under 1, we should have a vertical shrink by a factor of c. So let me go ahead, move this over to c equals a half, because that's really nice. Decimal, let's go ahead, turn off these function values because they're in my way. Okay, so if c equals a half, again, we're pretending that k is c. If c equals a half, then we should have a vertical shrink by a factor of c, or in this case by 1/2. So I guess I should turn them on. So in the purple graph, we have the original function value. So we're at 1, 1. And then we're going to shrink this graph by a factor of 1/2. So we're going to shrink all the function values by c, or 1/2. So if I was at 1, 1, if I have the function value, that will give me a 1, comma 1/2, and then let's go ahead and play with this for fun. So again, the purple graph is the original function. The green graph is the graph of c times f of x, where c is under 1. So the function value at x equals 1 is 1. And then I want you to notice that it just keeps shrinking. Okay, so that was pretty nice. So I'm learning to play with Desmos. So that's my disclaimer. Okay, thanks to my office mate. He's awesome. Okay, so we're going to go ahead, take a pause. And in the next viewing window, not next video, we're going to illustrate horizontal stretch and shrink. Bear with me, guys. All right, guys, I got the other graph up and running. So quick reminder. So if we are asked to graph c times f of x, we are changing the function value. So as a result, we're going to have either a vertical stretch or shrink. If c is greater than 1, we're going to have a vertical stretch by a factor of c. And if c is under 1, then we're going to have a vertical shrink by a factor of c. Now, let's just say that we took that same function and then we were asked to graph f of c times x. So what is going on? Am I going to have some vertical or horizontal action? So in this case, unlike the previous statement, we're not changing the function value. What we're changing is the x value. So the x value kind of reminds me of the x-axis. So we're going to have some side-to-side action. So we're either going to have a horizontal stretch or shrink. Now, what's going on? If c is greater than 1, so remember, I'm supposed to say if the absolute value of c is greater than 1, but that's too many words, so we're just going to focus on positive values. So if c is greater than 1, my mind wants to say, oh yeah, if c is bigger than 1, then I'm going to have a stretch, okay? But that's only when we have for a vertical case scenario. For horizontal, it's actually going to be the opposite. If c is bigger than 1, we're not going to have a horizontal stretch. It's actually going to be a horizontal shrink by a factor of c. But now, what if c is under 1? So again, I'm supposed to say if absolute value of c is between 0 and 1. So in English, or with fewer words, if c is a fraction under 1, okay? So if c is under 1, then we're going to have a horizontal shrink by a factor of horizontal stretch by a factor of 1 over c. See, I told you, sometimes I get confused. So going back to the vertical stretch or shrink, if c is bigger than 1, then we're going to have a vertical stretch. If c is under 1, then we're going to have a vertical shrink. For the horizontal stretch or shrink, it's backwards. If c is bigger than 1, then we're going to have a horizontal, not stretch, but shrink. If c is under 1, we're going to have a horizontal, not shrink, but stretch, and they're both by a factor of 1 over c. So let's go ahead, come to our Desmos area. Give me a sec. Okay, so the purple graph once again represents the graph of f of x. In this case, to be more specific, we're graphing the square function. So where am I? So yeah, so let's just say we wanted to graph f of c times x. So here we have it, f times c of x. And we're going to look at the case where c is bigger than 1. I'm going to focus on c equals 2 because I like number 2. So if c equals 2, then since 2 is bigger than 1, then we should have a horizontal shrink by a factor of 1 over c, or which is 1 over 2. So right now we're at 1, 1. If we have a horizontal shrink by a factor of 1 over c, then we're shrinking the x value. So if I'm at x equals 1, when I shrink it by 1 over c, or 1 over 2, I should be at x equals 1/2. Let's go ahead and move the slider. Think I just got it, and that looks like about a half. It would be nice if I actually turned on the graph. So let's do that instant replay. Okay, so if c equals 2, we have said that the x value should shrink by 1 over c, so 1 over 2, or a half. So let's go ahead and move the cursor to c equals 2, and as expected, we were at 1, 1, but we have a horizontal shrink by a factor of 1 over c, or 1 over 2, or 1/2. So that gives us x equals 1/2. So we're gonna go ahead play this. I'm just playing this between 1 and 5. Okay. So in this case, the red graph represents transformations of the graph where c is bigger than 1. As you can see, the x value, focusing on 1, 1, the x value is 1. And then since c is bigger than 1, then we're going to have a horizontal shrink. So let me go ahead, take a pause on that, and including the video because I need to get it ready for the other case scenario. Perfect. Okay, so I zoomed in a little too much, and the other one that the other function that I wanted to show you shrank. So let me go ahead, turn it on. Okay, so the green graph is now gonna represent f of c of x, where c is under 1. Okay, so again, I'm not allowed to use the same variable because I already used it. So we're just gonna pretend this says f of c of x. So the note says that if c is under 1, then we should have a horizontal stretch by a factor of 1 over c. So right now we are at 1, 1. Let me go ahead turn this labeling, okay? Yeah, that didn't look so nice, but it's okay. We'll let it play, okay? So we are at 1, 1. And then I'm just going to pick c equals 1/2, okay? So if c equals 1/2, then we should have a horizontal stretch by a factor of 1 over c. 1 over 1/2 equals 2. So we should have a horizontal stretch by a factor of 2. So let me go ahead and move the cursor to c equals 1/2. And decimal equivalent should be 0.5. I think I got it. So we were at 1, 1. And let me turn off this labeling because it's in my way. Okay, cool. All right. I moved it in. Sorry, guys. So the original function is the purple one. The transformation of the graph is the green one. So we were at 1, 1, and we had said that if c equals 1/2, then we should have a horizontal stretch by a factor of 1 over c. 1 over 1/2 is 2, so we should have a horizontal stretch by a factor of 2. So I'm at 1, 1, and we're stretching the x value. So 1 times 2 is 2, and that brings us to, and that took us from x equals 1 to x equals 2. So I'm not sure if I conveyed what I was trying to say, but my intentions were good. I'm going to go ahead and animate this for values of c that are under 1. So remember, the purple graph is the original function, and then the green graph is the transformation of the graph where c is under 1. And if c is under 1, we're going to have a horizontal stretch. So right here we have the x value that is stretching. Okay, so that is my time. Yeah, that is my time. Okay, we'll just stop this video here. Okay, guys, so I told you that was it, but I guess I told a little white lie because it's not it. But this time I do mean it. We're just gonna do these two problems and then we're good. Okay, so we have a fun problem to wrap up this video. So we are told that the graph of f of x is given, so that's A. And it says graph the following transformations. Then write the equations of the parent graphs and the equations of the new graphs. So let's go ahead, write the equation. So you can put y equals or use function notation. I'm going to go ahead, use function notation. So f of x equals, and this is one of the 6 parent functions or basic graphs. And that will give us f of x is equal to square root of x. And we are asked to graph 2 times f of x. So in this case, what is going on? So in this case, we're changing the function value. So it's going to be a vertical stretch or shrink. It would be nice if I can identify the value of c. So in this case, we are multiplying the function value by 2. So c equals 2. And if you look at your notes, it says that if c is bigger than 1, then we're going to have a vertical stretch. So we're going to have a vertical stretch by a factor of c. Vertical stretch by a factor of c. So what we are going to do is we're going to take all those function values and stretch them by 2 or multiply them by 2. Let me go ahead label these ordered pair solutions, the ones that are highlighted. Oh, look, teacher, so nice. So the first one is at the origin. So I'm at 0, 0. And then if we multiply the y value by, where am I? By 2, that should give us 0 times 2 is 0. Also, that's still 0, 0. Okay. The next one is 1, 1. But we're multiplying the function value by 2. 1 times 2 is 2, so that should bring us to 1, 2. The next point that's highlighted is, where am I? 4, 2. But we're multiplying the function value by 2. 2 times 2 is 4. So that should bring us to 4, 4. Now, if I did the math right, then when I take this function, if I'm stretching it by 2, it should look a little bit higher, and I think we did a pretty good job. So let's go ahead write the equation. So the equation of one of the basic functions is the square root of x, but we're multiplying the function value by 2. So we just take our function and then multiply it by 2. It would be nice if we graph the solutions. Okay, for the grand finale, so we have the graph of f of x, and we're asked to graph 1/2 times f of x. So in this case, we are multiplying the function value by a half. So c equals 1/2. And if c is from the top, we're multiplying the function value of something. So it's going to be a vertical stretch or shrink. The value of c is a half. Since c is a number under 1, then it's going to be a vertical shrink by a factor of c, which is 1/2. So if I take this graph, I'm supposed to shrink it by a factor of 1/2. So let's go ahead, take all these points and shrink them by a half. So if I'm at 0, 0 times a half is 0. So I'm still going to be at 0, 0 on the transformation. Okay, the next one is 1, 1. But we're shrinking the function values by a half. So 1/2 times 1 is a half. So that should give us 1 comma 1/2. 1 comma 1/2. I think that's about it. The next one that's highlighted is 2, 4. But again, we're shrinking the function values by a half. 1/2 times 4 is 2. So that will bring me at 2, 2. It would be nice if we had x values to the left so we can have a nice smooth curve. So on the left side, we have a negative 1, 1 if my eyes don't fail me. But we're shrinking the function by a half. 1/2 times 1 is a half. So that will give us negative 1 comma 1/2. The next and final one, I believe that's negative 2, 4. But again, we're shrinking the function value by a half. So 1/2 times 4 is 2. So that will give us negative 2, 2. Okay, so before we connect these points, I had said if we did this right, we're supposed to take this graph and then shrink it down by a half. Let's see if it looks like we did. It would be a little bit easier on the eyes if we graphed it here. Let's go ahead and do a quick sketch. So it will be something like, where am I? Negative 2, 2, negative 1/2, 0, 1/2, 2, 2. Okay, so it would be right here. So it's a little bit easier to see, but that doesn't look so nice. Okay, but this is what we're submitting for credit. So this is given by y equals x squared, but we're using function notation. So f of x equals x squared. And what did we do to the function? We shrunk it by a half. Okay, so that is my time. Until the next video. Thank you, guys.